Hello everyone. In this lecture, we are going to understand the concept of multiprocessor systems. Multiprocessor systems where multiple CPUs collaborate within a single system, which aims in enhance performance, accelerate operations, and it boosts the reliability. Now, let us understand how this multiprocessor system works. So the first important thing, it uses the shared resources. So multiple processors, it will use the shared common memory resources and the peripheral device. Now this processor executes the task concurrently. That means it gives you parallel execution. While the OS, it manages the CPU scheduling and the load balancing. So that is comes under OS management. And interprocess communication, that means the communication occurs via a shared memory. I told you earlier that it uses the shared resources, right? So shared resources means the memory resources as well as the peripheral device, right? So and it uses the message passing mechanism. So you can say that I'll instruct five of the students to do five different tasks at the same time. So all the students keep doing their tasks at the same time. That will result in a minimal time. I'll get the maximum output. So that is the concept of multiprocessor system. Now what are the key feature of multiprocessor system? So as I told you earlier that in a minimum time I'll get the maximum output, right? So that will increase my throughput, right? So multiple task processes simultaneously, that will give me higher output. Then scalability, that I can add more CPU. Suppose I gave you the example that I can assign a task, a number of tasks to 5 students to do it concurrently. Now if I think that that time is not efficient, right? So I can assign 2 more students, right, to do the same task, right? So here I can add more CPU anytime to improve my system's performance. That's called scalability, right? Then next comes fault tolerance. Fault tolerance means what? That in some scenario, in some difficult situation, if my one of my CPU fails, then the other processor can take over and that task will be completed, right, without any error. So that is load balancing, or you can say that OS manages that entire stuff. Then shared resources, I told you earlier as well that it will utilize the common memory. Even the peripheral device, that means like input devices, and it use the system bus for the transfer of data for the message passing system, right? I can explain this with one of the very common example. So let us take an example that a busy restaurant kitchen, right? So suppose imagine that we are having, like in a downtown, we are having one very busy kitchen, right? So and that we have a multiple chefs, right? Multiple chefs preparing their dishes, right? So here in our system, CPUs are, we can connect them with multiple chefs, right? And these multiple chefs are preparing their own dishes, right? But they are using the common pantry, right? So common pantry, the share pantry, right? They are like accessing, they have the access of all the ingredients from a central pantry system, right? So the same thing in a CPU, we have a shared memory, right? So processor, the CPUs are accessing the data from the common memory, right? Then in that restaurant, you might be heard that one head chef is there, and they will that head chef, he will instruct, he gives the order to the other chefs, and he coordinate all the task and everything, right? So here it's a OS, right? So what OS will do? So it will ensure that smooth workflow will be there, right? So it scheduling algorithms you learned in OS, right? So those scheduling algorithms, the scheduling and everything, that load balancing and everything, that comes under the task of operating system, right? And the result of that, what will happen, that every chefs are preparing their own dishes, right, based on that whatever orders they get, right? So the fast service will get the fast service, right? So here also in this system will give the fast service, right? Even for that, in that scenario, if one chef is absent, right, so other can pick up that order and complete that order. Similar way in our system, if one CPU fails, the other CPU allocated by the OS can take up that task and complete that task without any failure, right? So I hope you understood this simple example, right? Now in a real-time system, you must be thinking that where we are using multiprocessor system, we all are using it, but we are not aware of it, right? So the basic thing, the smartphone and tablets, you all are watching this video on your smartphones, right? Smartphones or tablets, right? So these are using, all the smartphones are having multi-core CPUs, right? And they do multitasking. You are running, you are playing Free Fire, right? And along with that, you are doing something else also, right? And 2-3 tasks in a backup, you like in back of the system, right? Some a message arrives, right? You are playing Free Fire, along with that you got a WhatsApp message, right? And you are replying that from that window, right? That is also happening. So that why it is happening, that is because of this multiprocessor system, right? Web servers, that is like right now we are having a web servers and everyone is using like websites and everything. So in our internet, there are thousands of requests made within a seconds, right? Every seconds there are thousands of requests, right? So there are thousands of requests that are handled by the server. How? That is also using the multiprocessor system only, right? Then scientific computing, that simulations, data analysis, right now everyone is using ChatGPT and everything, right? So that data analysis task, that CAD software, that simulations and embedded system and everything, right? Everything is done using this multiprocessor system, right? So that is about like we are using it, but it might be possible we are not aware of it, right? Now what are the advantage of it? You might be aware of it during this, that enhance the performance, right? Then second one, improve the reliability, because like if one is down, right, one CPU downs, right, then next CPU will take that task and complete. So that is a fault tolerance. Fault tolerance is the biggest feature of multiprocessor system. So it will improve your reliability, right? Efficient resource utilization, right? Because we are using the shared memory, we are using the message passing system, common bus system we are using, right? So it will optimize the multitasking, right? So we are using making a use of better hardware resources, right? And then it's a cost effective, right? So if I'm designing one CPU that is extremely fast, right? So for that hardware and everything, it is like economically very high for me. Instead of that, what I can do, I can use 10 of the simple CPU, like number of simple CPUs, to and arrange them, collaborate them to do to perform to work like that single CPU with the high efficiency, right? So that are the advantages of multiprocessor system. So ultimately, multiprocessor systems are foundational to modern computing, right? And it offers unparalleled performance, right? And the reliability, right? So this parallel processing, multiprocessor works on parallel processing, right? And it's a core concept for enabling the faster computation and system resilience, right? So I hope you understood this concept of multiprocessor system. Thank you very much.